Hi friend, today we are going to learn about simple vapor absorption refrigeration system. The basic principle of simple vapor absorption refrigeration system has been derived by Michael Faraday in 1824 while performing the experiments to liquefy the certain kind of gases. He has been derived principle that a peculiar property of certain substances having greater affinity with another substances, right? So substance if you consider A and substance if you consider B, so this A substance having greater affinity with B substance at some temperature and pressure conditions, and no affinity or less affinity we can say at another conditions, that is as pressure and temperature conditions too. So that is replaced by absorber, a pump, a generator and expansion valve. So these four components extra here they have been added. So the benefit of that is that the energy required to compress the gas is less, or we, instead of using the mechanical energy for compression of gas, we are here using the electrical energy, and only a part of energy required for the pump, that is mechanical energy, right? So let's see the working. In simple vapor compression refrigeration cycle, there are two basic working medium, that is one refrigerant, right? Refrigerant, and second absorbent. This is refrigerant and absorbent. So the basic function of refrigerant already we know that to get circulated in the system and produce the refrigeration effect or cooling effect by absorbing the heat from surrounding medium. And the second working medium have been added here, that is absorbent, right? So absorbent in this system, that is aqua, or we can say water. Okay, so water is a absorbent. So the basic function of absorbent is that to absorb the another substance at certain temperature and pressure conditions. So here water is have been used as an absorbent so that it will absorb the ammonia, that is a refrigerant, at certain pressure and temperature conditions. Okay, so let's see the working. So there are, as I told, the component, that is absorber, pump, generator, condenser, receiver, expansion valve, evaporator, and this is second expansion valve. I will tell you the function of that. Okay, now let's start from the evaporator. Already we know that the basic function of evaporator to absorb the heat from surrounding medium, whatever the medium present. So the refrigerant which is flowing through the tubes, right, of this evaporator, so it will absorb the heat from surrounding medium and it will get converted into the vapor. So cooling effect will be generated here, and refrigerant at outlet of evaporator will be in the vapor form. So that is low pressure vapor NH3, right? Ammonia, low pressure ammonia refrigerant. So that ammonia refrigerant will get absorbed towards the absorber. So in absorber, as we know that there is a water, they have been used as an absorbent. Okay, so it is it will absorb that ammonia. So because of the absorption of continuous absorption of ammonia, the temperature here will get rises. So to increase the capacity, absorption capacity, we have to reject the heat to the surrounding. So we have to reject some heat. So that is done by providing some cooling arrangement. So cooling coil has been used here. So cooling water is circulated, and so that whatever the medium present here, so it will be rejected to the surrounding, and because of that the absorption capacity of absorbent will get increases. Again, because of that the pressure in this will be decreases absorber, right? So by continuous absorption of ammonia, vapor and getting mixing with this absorber. This mixture, a very strong mixture will be formed. That is the mixture of low ammonia and aqueous. That strong mixture then will be pumped with the help of this pump to the generator. Right. So in the generator, again that mixture of ammonia, strong mixture of ammonia and water vapor will be heated with the help of heating coil. So external heat source is provided so that heating coil will generate the heat and will heat the particular mixture. So again, because of heating, so vapor will be developed, right? So NH3 vapor, strong NH3 vapor plus some quantity of H2O vapor, right? Some quantity of H2O vapor that will goes towards the condenser, and remaining portion, right, strong ammonia vapor will goes towards the condenser. Okay, and the weak solution, that is the ammonia vapor, right? So that is weak ammonia vapor plus water vapor will be circulated back through this expansion wall. So expansion wall is provided here, so that because of expansion, again pressure and temperature of that weak mixture will decreases, and because of decrease in temperature, again here will require some less heat rejection arrangement. So that mixture will be again supplied to the absorber. Okay, and then strong ammonia NH3 vapor will be supplied to the condenser. So this is the condenser. Again in the condenser, heat is rejected through these coils. Through this coil, strong ammonia vapor will be passes, and surrounding that there will be the water, right? So latent heat will be rejected by this ammonia vapor to the cooling water. Because of that, vapor form of ammonia will get converted into the liquid form of ammonia. So phase change process will be takes place, right? This is also, we know that is at constant pressure is equal to constant, and here we will get the ammonia vapor, ammonia liquid. Okay, that liquid ammonia will get stored in the receiver, and as per requirement, again then it is circulated through expansion wall and evaporator. So as it will passes through expansion wall, we know that the basic function of expansion device is to expand a particular medium, that is strong ammonia vapor, from high pressure to the low pressure. This process is carried out at a constant enthalpy process, so we can say that is a throttling process. And after throttling at low pressure, liquid form of ammonia will passes through the evaporator, and again the heat rejection will be done in evaporator, and same cycle will get repeated for the number of times, right? So this is the basic working. If you compare this simple vapor compression rate absorption rate cycle, if you compare simple vapor absorption rate cycle with the simple vapor compression cycle, so the COP of this system is low, right? So that is, we can say, the disadvantage of this cycle, right? But if you compare again, we can use here the heat energy, right? Heat energy we can use here. So that is the advantage of this simple vapor absorption cycle. And many plants, for the chilling of water or industrial or domestic purpose, this vapor absorption refrigeration cycle has been used. Okay, thank you.